Welcome, everyone. I'm James Shore, and this is the Art of Agile Development Book Club. Today, we're discussing continuous deployment, a technique for reducing the cost and risk of deployment by deploying multiple times per day. And who better to talk about it with us than Kelsey Hightower? Kelsey Hightower got his start as an entrepreneur at a young age. He was an early adopter of cloud technologies and now works as a principal engineer at Google Cloud, where he helps people and organizations learn to be better. He's a popular speaker and past chair of several high-profile technology conferences. His book, Kubernetes Up and Running, was co-authored with two of the creators of Kubernetes. It's now available in its second edition. Kelsey, welcome.
Oh, happy to be here.
I'm going to get things started by reading an excerpt from The Art of Agile Development. As a reminder, the second edition is out now in both ebook and print editions. You can get it from Amazon by visiting jamesshore.com/s/buy-AOAD2. And you can find excerpts and bonus material by visiting jamesshore.com/s/AOAD2. Continuous deployment. Our latest code is in production. If you use continuous integration, your team has removed most of the risk of releasing. Done correctly, continuous integration means your team is ready to release at any time. You've tested your code and exercised your deployment scripts. One source of risk remains. If you don't deploy your software to real production servers, it's possible that your software won't actually work in production. Differences in environment, traffic, and usage can all result in failures, even in the most carefully tested software. Continuous deployment resolves this risk. It follows the same principle as continuous integration. By deploying small pieces frequently, you reduce the risk that a big change will cause problems, and you make it easy to find and fix problems when they do occur. Although continuous deployment is a valuable practice for fluent delivering teams, it's optional. If your team is still developing their fluency, focus on the other practices first. Full adoption of continuous integration, including automated deployments to a test environment, which some people call continuous delivery, will give you nearly as much benefit. How to use continuous deployment. Continuous deployment isn't hard, but it has a lot of preconditions. Create a zero-friction, zero-downtime deploy script that automatically deploys your code. Use continuous integration to keep your code ready to release. Improve quality to the point that your software can be deployed without manual testing. Use feature flags or keystones to decouple deployments from releases. Establish monitoring to alert your team of deployment failures. Once these preconditions are met, enabling continuous deployment is just a matter of running deploy in your continuous integration script. The details of your deploy script will depend on your organization. Your team should include people with operations skills who understand what's required. If not, ask your operations department for help. If you're on your own, continuous delivery and the DevOps handbook are both useful resources. Your deploy script must be 100% automated. You'll be deploying every time you integrate, which will be multiple times per day and could even be multiple times per hour. Manual steps introduce delays and errors. So that is an excerpt of the continuous deployment practice in the Art of Agile Development. All right, let's get started with our first topic, organizational change. Kelsey, I know you have done a lot of work with companies about continuous deployment and continuous integration, and that can be a big mindset shift for a lot of organizations. What's involved with making that shift?
I don't necessarily subscribe to like the shifts and the journeys and the way people describe this today, right? You currently have some process and it got that way somehow. I think a lot of people have kind of lost touch about how it got that way. So whether you're doing it manually or you're using Jenkins, it evolved to that somehow. And so if you understand the current situation and you think there's room for improvement, okay, like who's going to do it? And ideally you get it done. I think a lot of organizations struggle with the very fact of, I don't know why it's this way. Everyone that made those decisions doesn't work here anymore, or they've moved on to other departments. And I'm just here now. I think it works. And yes, I have no idea how 500 of these apps are built, why they're even being deployed this way. Who wrote this in Corn Shell? That wasn't me. Should I rewrite it in Bash because that's what everyone's doing? Z Shell looks interesting. So you got all of these kind of situations that have kind of organically evolved to this. It's not like someone sat down 10 years ago and said, this is exactly the way we want the environment to look like. Between acquisitions, experiments, failed experiments that made it to production, all of these things end up in this situation. So when we try to pause and say, all right, now let's get strategic about moving forward. But it's like, well, you still don't understand what you currently have. So I think the first step is going to be just understanding. What do you currently have? And then who is going to take ownership, like raise their hand and say, I will be responsible for learning this. And then owning it all the way into it does change, and being honest with yourself that it may take longer than you want.
Yeah.
I think that's the reality.
Mm-hmm. And these sorts of scripts, they tend to be second-class citizens for a lot of teams, don't they? Where they were created by somebody at some point, and nobody really has taken responsibility for owning it or maintaining it since.
Yeah, I wrote those scripts. I know, like y'all know how this goes. You write the script until it works. All right, for I in server list equals blah. Okay, works great. Boom, put script in place. Jenkins turns green. Woo, CI/CD. I'm out. And then something changes, like someone re-IPs the servers, or we don't put war files in that Java path anymore. And then things break. So what do? You go to the script. You figure out what needs to happen now. If you're, before version control, most people aren't even version control in these scripts, right? It's like, deploy October 12th pre-COVID script, right? And then you got the post-COVID script. And no one knows why these scripts have evolved because there's not a lot of comments. It's just quick and dirty at that particular step times n number of things. So yes, I've been guilty of that, of just evolving these I don't remember using a deployment framework back in the day. You wrote the script until it worked and it stayed in its form.
Yeah. Yeah. I'm guilty of the same thing. It never feels like the thing that's really central, right? I'm trying to get features out the door. I'm going to just make this work. But I always end up regretting it down the road because when I look at it again, it doesn't make any sense. And I don't feel like I can make changes safely without, potentially breaking anything. So what do you do when people, now, I don't know that I fully understand how you work with organizations. I did some reading on what you do, and I got the impression that at one point you were being brought into organizations to help them get stuff set up, help them get Kubernetes set up or other cloud systems. Is that right?
Most people know that I've worked in this industry for a long time. Mm-hmm. I've worked at companies like Puppet Labs, where we try to infrastructure as code the world. I was at CoreOS when we were trying to bring containerization to the world. I was an early contributor to the Kubernetes space. But I think what companies do, appreciate is the empathy I have for the real jobs to be done. And throughout my career, I've kind of bounced back and forth from companies building technology to companies that actually have to use technology to get something into production. And so a lot of times when I'm meeting with, whether it's a C-suite executive and they just want to know, like, what can I do to help my team? Normally I'm like, just get out of the way. If you don't understand what needs to happen, don't pretend you do, and kind of stay out of the way. And then if you're going to hire good people, let them be good people. And then when it comes to practitioners, yes, there's a natural curiosity. Is this better? And I say, well, I can't tell you until you show me exactly what you're currently doing. And for a lot of people, we have this saying at Puppet Labs, most infrastructure as code project was about us trying to give these systems that don't have APIs a deployment API. Like a Linux server is very raw, like a combination of SSH, RPM, init scripts that kind of glued together some deployment target. And what we tried to do was layer on these kind of DSLs on top. With things like Kubernetes does have a deployment API, right? Now we officially have something that says you get to describe your deployment versus script out your deployment. And so that's a big mental leap for people who've never interacted with the system that had a very explicit kind of deploy scenario baked into it.
Yeah, yeah. So I'd love to hear from all of you in the audience. Again, this is a call-in show, so just raise your hand in Zoom to participate. Love to hear your experiences with moving to continuous integration and deployment and what you've done to help make that happen. Is it just a matter of your executives getting out of the way and allowing you to get the work done? Well, I'm going to let people chew on that for a moment, Kelsey. And I want to talk about the automated build and automated deployment. You had just talked about, Kubernetes has an API, which is nice to actually have an API. What are some important things to keep in mind when you're building automation around automated build, continuous integration, continuous deployment?
I mean, I always thought automation was a byproduct of understanding. That just has always been my position, right? So let's just talk about like you're writing an app for the first time. The team has some servers that are out there and you have SSH access, right? They just start from that base level of principles. Now, you just wrote this app. I don't know, it's an HTTP API, works fine on your laptop. So what's necessary to go from that situation to the server? And so to me, I always started by just writing down the steps. Here's the build command that you run to produce a binary. That binary may have dependencies like other libraries, dynamic libraries. So yum install these things to get those in place. You copy binary to server. Does it work? No. Oh, I need to yum install some more packages. You keep notes. And then you blow it away and you try it again. Does it work? Build, deploy dependencies. Does it start? Great. Create an init script so you're not starting it manually. What does the init script look like? Blow it away. Try it again. Once you have all of that understood, then that documentation becomes the runbook. For some companies, that's what they have. Here's how you get this software to the servers, and you can do it repeatedly by copying and pasting from this runbook. Bonus points if you put reasoning why. Next step to me might be a script, right? You take the runbook and you turn it into a script, and you run the script, and it does the exact same thing. Once you have all of that understanding, now you can say, all right, let's just break this up into a more disciplined approach. And this is where I think kind of that idea around CI/CD comes from, where maybe there is a build step and the build step produces an artifact, and we take the artifact and we put it in a repository because we don't know what server the QA team may want to use for testing. We don't know what server will be used for production. So we decouple those steps. And then you might do some testing like fuzzy testing or static analysis for vulnerabilities. Either way, all that should result into an artifact. And then to me, I've always liked to decouple the production of an artifact from the actual deployment or release process. And if you do that, then I think you maintain flexibility. So the QA may have a workflow for swapping out what's under test, and the production team may have a workflow for rolling things out in a safe manner. But I think that is kind of the foundation. When I think about automation, it's all predicated on understanding what needs to happen, documenting that thing, getting consensus that, is this even a good process? And then we get to the pipelines. But I've seen a lot of people do this backwards. They start with pipelines, they brute force them into working, and then you just got this black box of like, I don't know, you put code here and something goes to the servers. And of course, no one knows how to change it because they have no idea how you arrived that this was the right pipeline in the first place.
Yeah. So this is a fair amount of work to figure out. I love the fact that you're talking about what we need to do is create understanding, and then from understanding, we can actually do some proper engineering. And let's go ahead and let David come on up. David, welcome to the show.
Cool, thanks. I just wanted to very much, I think, resonate with what you said there, and also, by way of a story and by way of James's request, there was an executive team that asked me to come in once to do this. They wanted continuous integration, and I'd just been at the Agile conference where they'd heard about it, and I knew the team that they were going to be going relatively well, and I knew that their deployments at that stage was a Word document, which for risk control reasons had to be written fresh every time. No one was even allowed to copy paste that thing. And then, it got deployed, and then ops had to, who weren't the developers weren't allowed to touch production, had to manually bring the whole thing up. So my first activity there was to rebrand continuous integration, reliable deployments. And we even had mugs made for reliable deployment. And so just like a complete agreement or just feeling of alignment with our first step is, can we get this thing reliably into production every time? Because there's normally a week after they've deployed of finding which config setting someone had forgotten to type in somewhere, because it was also manual. So that was super interesting. And also your point about the run book. Maurice de Beer was a friend of mine, and he used to talk about prison accounting. You know how prisoners etch the marks on the wall? And I've taken this approach a number of times with a team. Just like etch those marks when you do your deployment and count how many there are. Like, are there 67? Great. Now let's make our goal to make it 66 next time. And, that's been like a chip away approach. So yeah, it's really interesting to just hear that flowing through all the way. Just adding there, James.
Thank you, David. Any comments on that, Kelsey?
No, I think it's exactly right. And I think, the industry has forgotten to weave in the patience component. When I think about Agile and in this genesis, like people are trying to copy Toyota, a corporation with factories, proven ability to ship millions and millions of cars. And their number one problem is which car to build, not how to build a factory. And most enterprises have not agreed that they even need a factory. So trying to skip ahead to like this agile manufacturing methodology when you don't understand that a factory is required, it's not optional. And so I think that's where a lot of the tension comes from. I don't think people really understand where this idea actually originated.
Jay has a comment. Jay, welcome.
Hi. So I have a story, and maybe there's a question in there. I hope we can find it. I joined one team where the developers were directly responsible for deploying to production. There were no other ops people. We would take turns around robin deploying to production. And when it became my turn, they said, Jay, go for it. I said, well, how do I do this? They're like, oh, it's totally easy. And then one person explained the process to me. Another person said, no, you should do this other thing. It turns out that each person deployed differently to production. So my first step there was to gather everybody's thoughts about how to do it, write them down in a document. Hey, there's 14 steps. That's how we deploy to production. Let them argue about that until they found their steps. And then I got this strange objection. If you've written down the steps in the doc, why didn't you automate it? Shouldn't this be automated? Yes, of course it should be automated, but that's going to take more work. So it seemed really valuable to at least first write down and get some consensus on the process. And then I learned this technique of if you have a doc of steps and automating is going to be a big task, first write a script that prints out the steps with like a press enter to continue and let a human carry out those steps with the script directing them. And then bit by bit, turn parts of that into actual automation. I thought that's a great idea. This will allow us to incrementally move from a manual process to a fully automated one. As I started to do that, I got a really strange objection. People didn't like the computer telling them what to do. So that was an issue. We're trying to find the right balance there between how much is the computer involved and how much is a human involved. The other challenge I ran into with that is if you're going through a manual process as a human and something goes wrong, it's easy to adapt. And if a really simple-minded script fails on step 5 out of 14 and blows up, what do? Can you just run the script again? Or like, is it reentrant? That turned out to be a big challenge as well. Anyway, maybe you could riff on that, your insights on that space.
Thank you,
Jim. Yeah, so that is the problem with scripts, because to think about computers, there's that saying that no man can cross the same river twice because the man in the river will be different each time. And computers work the same way, whether you're talking about time or just entropy. That's just how computers work, actually. So when you run a script, most people are just getting lucky. You're just getting lucky that you didn't trip up over some weird thing that your script didn't account for. And to make something that can account for every scenario, the script will be unreadable. And so this is why now, like this concept of promise theory, which a lot of the config management tools tried to lean on, but they were missing one major thing. Config management tools, Puppet, Chef, Ansible, right? This is like the step up from scripts. Those are more like scripting frameworks, because what they were really doing was generating scripts. If you ever looked at what went across the wire, these Ruby DSLs or YAML DSLs, they really just printed out a bunch of scripts that were then executed on the server. And this is where we get into the run it multiple times until it works mentality. The difference, like when I saw Kubernetes, people were like, why was I so interested in Kubernetes? Given the prior like 10, 15 year history of doing things in this manner, when I saw Kubernetes says there's no more scripts, we have a clean API that says you can only give me your intention, like the true meaning of promise theory. And then the backend controllers would actually build these state machines that knew how to resolve state because they had complete ownership over the entire equation. The node, the application, the contracts were way more rigid. So when you say deploy in the Kubernetes world, you're not saying select machine with the most free amount of memory, put this in this path, and then do. No, in Kubernetes world, it just says, I will attempt to resolve this state forever. And so if a machine goes away, your intent is still clear. I'll just try the next machine. And yeah, it's hard. You're not going to get it right day one. But over decades, those controllers will account for all of these use cases where, now that we're sharing this as an industry, when company A has a problem, it will contribute to a better control loop that manages that particular declaration of what a deployment is. So now that it's been about 10 years for Kubernetes, we have thousands of people who have contributed to making that solid. So now when you call deploy, the degree of it working consistently is very high. And bash scripts take a ton of work to ever get to that level of reliability.
Yeah, one of the things I loved about Puppet when I first heard about it, and also about Kubernetes, is this idea that we're going to declare this is the state we want you to end up with. And you figure it out and you work it out. And I remember that I talked to the folks at Puppet a while ago, and I remember them telling me, well, testing this and making sure it really works under the covers is really hard because there's so many different things that can go wrong. But it's really nice to be able to say, well, I've got a tool that's battle tested and it's gonna make sure this works for me. Now you used a phrase a couple of times that I'm not familiar with, and I'm not sure if everybody else here is familiar with. It's promise theory. Can you say a little bit more about that?
Yeah, we did. Promise theory originates from a computer scientist, Mark Burris. I know him. He's based out of Europe. He's written a whole book about it. And he also was involved in an early configuration management company called CF Engine. And they were trying to put this to work. But again, it also suffered from that scripty interface mindset. And I remember when Kubernetes first came out, me and him had dinner, and I showed him Kubernetes. And I said, I believe that this is probably what you meant. And I showed him how Kubernetes worked. And he was like, yeah, this is much closer to the concept of promise theory I was trying to describe. And I was in a recent documentary. So we did a documentary about Kubernetes, and I gave this description of promise theory. If you think about the post office, right? You want to send a letter to someone on the other side of the country. And so the interface you have is a letter, the address field, and the postage stamp. That's your contract. That's your declaration. I want what's inside of this envelope to go to the other side, and I pay my postage. What you don't do is put instructions, like you don't put directions to this person's address. You don't talk about mail trucks or airplanes. You don't talk about any of that. And so when you go to the post office, they make a promise when they accept that letter. You've paid your postage. We guarantee that it should get to the other side. And some delivery mechanisms will have a tracking number. And that tracking number can be representative of the promise. So I'm making progress behind the scenes. A mail truck has broken down. I'm not going to contact you because that wasn't part of the contract. The contract is I need to find another mail truck and get your letter to the final destination by any means necessary. And so this promise theory is that when we build systems this way, so in the case of things like Kubernetes, we're saying, here's the data you need to give me about what you want your deployment to be, and I will do whatever it takes to converge the real world to meet that promise. And so it helps us design much better systems because we don't leak implementation details. Scripting doesn't do that. Scripting says, for this server with this IP, do exactly these things. No, that's very explicit. So when the server goes away, the promise is immediately broken because the script is only written for that scenario. And then there you're done.
Mm-hmm. Mm-hmm. Abdul, I see you have your hand up. Welcome to the show.
Hi. So I've got a couple of questions. The first one, artifacts. So what should an artifact be? And we've got a lot of options here. And traditionally, going back in a few years, it was just the application on the server. Then we had an opportunity to do VMs. Now we've got opportunity to do Docker. And all of these bring benefits. They're smaller artifacts as we go through there. They're easier to manage over the generations. And when you get to things like Docker, you've even got developers who are on board and they understand it a bit better and things like that versus just ops people. But as an ops person, I tend to struggle with that because if we go in Docker, then our ops environment tends to become a bit more complicated, whether I'm going to go with something like Kubernetes or Docker Compose, and there are lots more moving parts. So that's my first question is how do we make decisions about what this artifact should be? And then my second question
let's let Kelsey respond to the first one.
When I hear questions, I always try to think of a good analogy. So when you think about operations, think about the evolution of packaging at a grocery store. Right? And think about the early markets, right? You go and there's just salt. What kind of salt is it? I don't know. It's salt. What's the price? I don't know. Put the salt in a bag. I'll weigh it and I'll tell you how much it's going to cost you. And so if you're trying to bake a cake, you're in operations, right? I just need salt to do whatever I got to do. I'm trying to bake something. So I go and get ingredients, and the ingredients are just raw. I got to I got to bring my own measuring cup and be like, I need this much. And it's like, this is not repeatable. The salt may be different, or the eggs may be different tomorrow. It may not taste the same. And so I have to do a lot of work to make this work. This is actually really, really hard. But if you've been doing it for thousands of years, it's just second nature. You bring your stuff to the market, you bag it up, you pay for it, you go home. Fast forward 1,000 years. You go to the grocery store, there's labels. This is 16 ounces of salt. Here's a carton of eggs. Here's where they came from. Here's the nutritional facts. And then we get recipes like cookbooks, because people have been baking things for a long time. And so now you get the recipe, you go to the store and you pick almost exactly the ingredients with the exact quantities. It's almost like they package things in the grocery store to fit the recipes. You ever noticed that? Most things are sold at recipe quantities. And so now that you have recipes, it becomes easier for everyone involved in the chain. And so if you're a developer, what's an artifact? To me, it's all about composability. If I'm a library developer, then I'm going to produce an artifact in that native thing. So if I'm doing Ruby, it's going to be a Ruby gem. If I'm doing Golang, I'm going to be doing a Go module. If I'm doing Java, you get the idea. Because these are composable artifacts. That's the contract I have with whatever's upstream for me. Now, if you're a developer building an end user application, your goal is to compose other ingredients to produce your artifact, which may be a WAR file or a native executable. At the end of the day, that will be your artifact. Where do you store these things? Well, you store them where the ecosystem lives. Ruby gems go where they go. Python libraries go where they go, so that build tools can compose the other artifact. Now, once you have the other artifact, let's talk about what's the destination. If my destination is just SCP to a server, then yeah, maybe I'm just going to be fine with the actual Linux executable, and I'll just copy it to the server and be done with it. But maybe I want to use a package manager. Think about the composability. We're still going to create the executable. But then we may couple it with an RPM spec file so that we get an RPM, the Red Hat package manager. So now that we can put it in a Yum repository that has metadata, we can attach signatures to it. And then the rest of the world can do Yum install our application, because it comes in this nice, convenient to use packaging. It's like the eggs with the carton and the barcode. And now Docker comes out and everyone's like, oh, now we got to rethink everything. Absolutely not. You can now take the RPM in your Docker file. You can say Yum install the exact same RPM from 15 years ago, and out pops a Docker container image, which is a fancy tarball, by the way. And now you can put it in a container registry, and then serverless platforms can pull it. Heroku can pull it. Kubernetes can pull it. Docker can pull it. Anyone can pull it. So the way I think about artifacts is it's just a layer of composability depending on who is going to consume it. So that's the way I think about artifacts. And then if you decouple that, how you use the artifacts, those are recipes. So you have eggs and you want to bake a cake, get a recipe. You have a container you want to deploy to Kubernetes, then you get a recipe, which is that YAML file that tells Kubernetes how to deploy the app. So for me, my whole career, I've always kept these things separate. And it's been easy for me to adopt every generation of these tools because they just build on each other.
Yeah, actually, I like that a lot. I think the challenge I was having is that as we got to Docker, it seemed like developers were starting to want to influence or want to deliver Docker containers instead. This idea of if it runs on my machine, it's going to run on a server. So I'd like to deliver a Docker container. I think what you're saying is that the developer should really be focused at the package level, right? The sort of how you're going to package your application and then operations should be concerned about how that's going to work in or get installed in a running environment. Like the developer shouldn't be influencing the running environment.
The developer probably should be influencing the running environment. It's just the contracts in which we capture this influence, right? So, right, like I've been there. Developer says, here's the app, it works on my machine. You put it in your system, and then the dynamic libraries are missing on the server. We get in the war room, it's like, oh yeah, I need libxml 2.4.5.
Right.
The symlink is missing. My app doesn't run. Like that is a huge waste of time. Like that literally is not the goal of the team. So now I'm saying, I'm going to deliver you a package that has all my dynamic libraries. It has everything I need. And so we're not going to ever have to play this game of what's on the server and what's my app needs. So I'm going to give you something that's actually ready to go. But here's another problem. I make system calls, right? There's still a kernel. And so if your security settings are so rigid that my app doesn't run, I have to give you some influence. I have to tell you, I need these 12 system calls. So I might give you a Kubernetes config or a Docker compose file that says, here is my runtime specification. I need a mount point. I need a config file. I need a database password, right? The contract is more. So Docker container is the envelope. That influence in the runtime is the address. How are you going to deliver it if I don't give you the address? If I give you the address without the zip code, you're probably going to deliver it to the wrong state. So what we want developers to do is to have a clearer contract. Look, you can influence the runtime. You can tell me where you would like things to be mounted. You can tell me what type of configs you need. And then if I see that, I can then say, will we do things slightly differently? We're going to mount things using NFS and not an SSD on the machine. So, but I see where you would like that data to be mounted, and I will honor that contract. So I think that's really where the tension lies, is that in order to get this kind of certainty, we just need better contracts up and down the stack. And yes, it's confusing now because as an industry, we went from mainframes to pizza boxes to config management to bash scripts, and now to Kubernetes. And all of those things are alive and well at the same time, and it's hard to choose.
Thank you very much for your comments, Abdul. I know you had another question, but I actually want to change gears because we're running out of time. I want to talk about data migration, Kelsey. That often involves big, irreversible changes. We had Kent Beck on a couple of weeks ago, and he was talking about evolutionary design. He said, well, one of the things that makes evolutionary design work is that actually most of the work we do as developers is actually reversible. And so it doesn't matter what decisions you make, because if you get it wrong, you can go back. Data migration, not the same. So what kind of tricks do you have for data migration?
Yeah, I remember like when I first started as a developer, and I remember earlier in my career, I used to use like the Ruby kind of rake migration process, like Ruby on Rails. They had this nice fantasy, right? You could write your apps in a certain style, baked in ORMs, and it just felt like everything was one-to-one. Like the code was like one-to-one to the database schema, even generated the database schema, and it worked for you until it didn't. Mm-hmm. But there was this kind of idea that I can just call rake migrate and everything will be fine. And then you think about the race condition there, right? The app is online and you call migrate. When you have a little bit of data, it seems to go so fast that almost no one recognizes that you actually dropped a few connections, but who cares? It's fast enough. So be it. Don't tell anyone, I won't say anything. But then reality sets in. That rate migrate takes 2 hours because your data set is much bigger. You have more indexes than before. That B tree is getting big. The disk is getting slow. You ran out of inodes. Like you ran rake migrate and it said out of inodes. And you're like, what's inodes? And so now you realize that you just can't be doing this process where you just migrate the database on code deployment. That's kind of insane and dangerous. Most people were just getting lucky. So one thing I've learned, like working in financial services in production, what you realize is that some of the performance optimizations you make in certain environments are dictated by the use case, the amount of traffic, the amount of data you have. So as much as you want to put all those things in the same environments, sometimes just the size of data and complexity changes things. So one thing we got really good at was making database changes independent of the app. And whenever I was in charge, I've always said, hey, listen, here's what I prefer. If we're going to introduce a new schema, it needs to be backwards compatible. So in one window, you're going to change the schema and the app should still work and reports should still run. Then we're done. Hey, congratulations. We have a new schema. Let's let it bake for a couple of days. Okay, let's just keep it working. Now in the lower environment, you have the new schema as well, but you also have a new version of the app. We're good. Now we have the sameness database schema-wise in production and the lower environment. Gives the developers time to iterate. By the time we get to production, it's a beautiful thing. New app goes out, attempts to use the new schema, something is broken in another place. We can actually roll back to some degree because we preserve the ability to, because of the way we've made our schema change. And honestly, I know a lot of people don't like that because it feels like a lot of crust starts to build up. because backwards compatibility tends to have this extra column that you wish you can just get rid of and migrate to the new column name. But that's irresponsible. That's not how systems evolve over time. What you may have to do is like, hey, we're going to have to wait to 2 releases before we can think about removing that column. And also, what about the old reports? Who's going to go update all the report queries? So this is what I mean by maturity. Maturity may call for some different types of ways of doing these things. And that's the way I ended my career in terms of just being very pragmatic and thinking about what happens if things goes wrong and giving people a safety net just in case they do.
So what you're saying then, if I understand you correctly, is you can change the schema as long as it's still compatible with the old code. But that does lead to cruft. Does that cruft ever get cleaned up, or is it just stay out there?
Well, so here's the thing. If you can't clean that cruft up, then you probably couldn't have migrated us safely going forward either, right? Like, so to me, it's like, this is what I mean by engineering discipline. If I say, let's say you put the new schema, I also want to know how are you going to clean it up? We can demonstrate that in testing, right? So, hey, Kelsey, we propose that we want to roll forward with this new schema change. Great. So let's write down what's going to happen. You're going to add a new column, all right? Like a very concrete example, people used to do address fields where one big string in one column. It's like, dude, this is crazy. We should probably break that up into like 5 different fields, street, apartment number, city, zip code, et cetera. And so now people are like, all right, we want to get rid of that string. I'm like, well, pause for a second. We don't even know who's all using that particular thing yet. So here's what we're going to do. We can write a script that takes the current strings and reflects them into the new columns. We can do that. So we can make sure that we're going to allow null for now. We have some constraints. And then what we're going to do is go back and clean everything up to match that new schema. So we'll do that in QA and we'll run it. So now we have the old column and the new column in place. All right. Everything looks over. We were able to move the old data to the new thing. Great. And so what we're going to do now is make the same change in production, independent window. All right. Everything is in place. Everything is working. So what do you guys want to do now going forward? Now what we've got to do is observe the table usage. Is anyone ever using that column? Right? We can monitor that. And when that gets to 0 for 30 days, you can drop the column.
Okay. So you're saying you can clean up, but what you need to do is make sure that you've really finished the migration. All the code that used to depend on that old column is really, truly gone, because how do you know if it's all gone? Well, you can monitor it in production. That is fantastic. I wish we had more time. I wanted to talk to you about feature flags and keystone interfaces, but we are out of time for today. Kelsey, thank you so much for joining us.
Hey, thanks for having me. And also to all you all that decided to use your time to hang out with me today. So I appreciate it.
Yeah. Kelsey is a principal engineer at Google Cloud and co-author of Kubernetes Up and Running. Next week, Todd Little is going to be joining us. We're talking about forecasting and roadmaps. That's a topic that many teams struggle with, and Todd has a lot of great data and experience in that topic. His work is the basis of the discussion on date and scope forecasts in the art of agile development. It's sure to be a good discussion, so be sure to mark your calendar for June 3rd at 8 a.m. Pacific. The free reading is up at jamesshore.com/s/AOAD2 book club, and you can join the Discord conversation by visiting jamesshore.com/s/AOAD2 Discord. Speaking of marking your calendar, the following week, on June 10th, Johanna Rothman and Elizabeth Hendrickson are going to be joining us to discuss agile management. So be sure to put that on your calendar as well. That is it for today. Thank you very much for joining us, everyone, and I will see you next week.